Um, so for the last presentation, the last talk of this morning, I will let Aurélien Bigo talking. So he's a researcher in the field of transportation, energy transition of transport, and he worked for the ADEME he contributed to the transition 2050 scenarios. So this is scenarios and levers of transition in the transportation sector. So I will let you begin.
Thank you. Firstly, I'm sorry in advance for my English, which is not as good as the two previous speakers. So my research focuses on transport emissions in France, and I will present you some past trends in terms of transport emissions in France, also some future prospects in terms of decarbonization of the sector in France, and what are the different drivers, what are the different levers of energy transition for this sector, and what are the different interactions with ICT. ICT is not my specialty, but I will try to show how there are a lot of interactions possible with the different drivers of transport emissions. So first, here are the past emissions for the transport sector in France from 1960 to 2019. So we see that there were a strong increase in domestic transport emissions for the late 20th century. And for the last decade, the transport emissions are quite stable. Here are only domestic transports. If we add also the emissions from biomass, because biofuels are considered as neutral in the countability, but in reality, there are also CO2 emissions from their production and from the possible land use change for their production. So if we add these biomass emissions, we have stable emissions since the beginning of the year 2000, and with international transportation, especially with the increasing emissions of the aviation sector, we also have a lot more emissions than only for the domestic transportation. But I show the curve of domestic transportation because it's the perimeter for the national target of the SNBC, which is the National Low Carbon Strategy, which aims at reducing transport emissions in the next few years and almost target full decarbonization, at least for the terrestrial transportation. So no more oil consumption for EV trucks, for cars, for buses, coaches, for trains, and all the terrestrial transport modes in 2050 need to be fully decarbonized, so no more oil consumption in 2050. So climate change is one of the important focus in terms of sustainability for mobility, but it's not the only one. There are also other environmental, social, health impacts of our mobility, and these are also some externalities, some challenges for sustainable transportation. So first, there is the challenge of climate change. Also, another challenge which is related to energy transition is the impact of air pollution and its health impacts. There is also challenge in terms of resources scarcity for oil, but also for other materials, other minerals. There is also a challenge in terms of land and space consumption, as especially our mobility and especially for cars, which take a lot of spaces, especially in urban areas. There are also externalities in terms of noise pollution, in terms of road safety, in terms also of physical inactivity and the health problems the problem it means also for our health. And finally, there are also other externalities, but also the social and territorial inequalities in terms of mobility access, which is also another important challenge in terms of sustainable mobility. In order to reduce the CO2 emissions of the transportation sector, the low carbon national strategy mentions 5 different drivers or 5 different levers of transport emissions. I will show you some trends, some past trends, and some prospects by 2050 for these different drivers. The first one is about the moderation, the limitation of transport demand. Transport demand is considered as the number of kilometers for passengers. So with more proximity or with different territory planning or different behaviors, we can try to reduce this number of kilometers traveled by the passengers. The second one is about the modal shift, so to shift from cars and planes to public transportation, active transportation like biking and walking. The third driver of transport emission is about vehicle occupancy and especially the potential of carpooling for passenger and for cars. The fourth one is about the energy efficiency of vehicles, so how much energy they consume. So there are things like technological levers, like improving engine efficiency, like electrifying the transport fleet, but also some drivers more in terms of sufficiency, like reducing the weight, reducing the speed of the vehicles, which can also eco-driving also, which can also reduce the energy consumption of the vehicles. And finally, the last one is about reducing the carbon intensity of energy, or the decarbonization of energy, which is to stop to reduce oil consumption, to go to electric, to hydrogen, to biofuels, if this energy are produced in a sufficiently decarbonized and sustainable way, which is not always the case for these different energies today. And in terms of implications, or in terms of possibility to drive these different drivers, some of them are more focused on demand side drivers, or like sufficiency levers, and the other ones, more at the right of the picture, are more focused on technological evolutions, and we will see for the past or future trends what are the implications of these different drivers. So before that, some other interaction, or another thing which is very important for these different drivers is that there are a lot of different interactions for these drivers with different components of the energy transition, and each of these drivers are influenced by a lot of different things, especially by public policies, but also by the energy and resources we have for transport, about the different characteristics in terms of transport modes and what are their speed, their costs, especially the interactions with economy, with demography, with territory planning, with lifestyle, with technologies. So for the link with ICT, ICT can be linked to a lot of these different components of the energy transition. It can influence lifestyles. It's also a technology. It can be influenced also by public policies, but we see also by this picture that ICT is not sufficient alone to drive the energy transition. There are a lot of different components to take into account in order to influence these different drivers of transport emissions. And these different drivers are related to these three main challenges of the energy transition of transport, which are to reduce CO2 emissions, to reduce air pollution, and also to reduce the oil dependence of the sector. And it's also related, as we have seen, to other externalities. Here are some trends for these 5 drivers and how they have participated in the past trends of transport emissions in France, especially for passengers. I will not show you the trends for freight, but there are a lot of similarities with the passenger transport sector. So for the past trend of passenger CO2 emission, we see that compared to base 1 in 1960, the CO2 emissions of passenger transport have been multiplied by 4.2 in this period. And then we can see what is the contribution, what is the contribution of the different drivers to this CO2 emissions evolution. So the first drivers is about transport demand, which have been multiplied by 4.7 on this period. And it is due partly to the increase in the French population, which increased by 43%. But even more, it's even more due to the increase in terms of kilometers per capita, which multiply by 3.3 on this period. And the other thing that we can see about the interaction, the close link between transport demand and CO2 emissions is that there have been very few decoupling between these two parameters in the past years and decades, and this is due to the fact that CO2 emission means CO2 emissions by kilometer traveled have really decreased. Not a lot, only a few decrease of CO2 emission by kilometer traveled, and this is explained by the fact that except transport demand, the 4 other drivers have mostly compensated each other for the past decades. So there have been two drivers which contributed as transport demand mainly to the increase of CO2 emissions. It's firstly the modal shift, which contributed to an increase of 22% of CO2 emission on this period, and it's especially due to the shift from walking to car at the beginning of this period. And the other factor contributing to the increase of CO2 emission is the vehicle occupancy, which have decreased on this period. So we need more vehicles to transport a given amount of people. And finally, the two drivers that have evolved in terms of reduction of CO2 emissions are firstly energy efficiency of the vehicle, which improved on this period quite regularly in the past decades. Sorry. And another driver is the carbon intensity of energy, which decreased a bit on this at the end of the year 2000, but in reality, as I've said before, there are a lot of, when we take into account the global life cycle analysis of their production, finally, they are not really better than oil today for the biofuels which are used in France. And what we can see also from these past trends is that the drivers, the first drivers of the decomposition, which are more focused on sufficiency drivers, have evolved mainly in the direction of more emissions, and the drivers of technology have mostly participated in the decrease of CO2 emissions, but not sufficiently to compensate the wrong direction of sufficiency drivers for the past decades. And another thing about the past trends is that for the moment, the public policies in terms of environmental public policies for transport have had a little impact in terms of CO2 emissions reduction for the sector in France, and the emissions are mainly driven by other impacts like economic impacts and oil and the rise of the price of energy at the beginning of the 21st century, that also implied this cap in terms of CO2 emissions at the beginning of this century. And then I will pass to the prospects by 2050 with the same kind of decomposition of emission, and in order to know how the national low carbon strategy how the targets of reaching decarbonization of the transport sector, and especially for passenger, how it is, what are the main drivers for this for the decrease of CO2 emissions. So here we can see between 2015 and 2050 the curve of CO2 emissions reduction for passengers, and then we can see what is the relative contribution of the different drivers. For the first drivers, it's projected to grow by 26% by 2050. So it's not a driver allowing a reduction in terms of CO2 emissions. Then the second driver is about the modal shift that allows a reduction of 8% in terms of CO2 emission. The third driver is about vehicle occupancy, allows a reduction of 11% in terms of CO2 reduction. And what we see is that the main contributions in terms of CO2 emissions are due especially to energy efficiency gains, and also to carbon intensity gains to reduce CO2 emissions. And this graph is only in terms of direct emissions, so it doesn't take into account the emissions from the production of energy, from the production of the vehicles. It's only direct emission from the transportation sector. But where we see both on this multiplicative form of the decomposition, of this additive form in terms of million tons of CO2 abated each every 5 years, that the main contributions in terms of CO2 emissions reduction from this strategy comes from technological options, and especially from the increase of the share of electric vehicles for cars. So the strategy is mainly focused on technological options. And in my thesis, I asked myself if other French scenarios had different outlooks in terms of potential of these different drivers to reduce the emissions by 2050. And for that, I compared 13 different passenger transport scenarios in France. I won't show you the details of this figure, but only just to know what's the methodology is that I have here the results of the previous figure of the French National Low Carbon Strategy, and I compared this strategy with 4 other scenarios which are trend-based scenarios without a strong ambition on energy transition, and with other energy transition scenarios where the CO2 emission reduction is much more pronounced than for the trend-based scenarios. And here is the figures that summarize these results for each of the 5 different drivers. So especially for transport demand, we have seen that the national low carbon strategy projects an increase of 26% of transport demand, but we see that compared to other scenarios, this is a strong increase in terms of transport demand, while other scenarios which are more ambitious on the energy transition is the mean of the 4 more ambitious scenarios of this on this factor, on this driver, as they projects a reduction of 10% in terms of kilometers traveled by the passengers. So on this driver, on this first driver, the national low carbon strategy is not really ambitious compared to other scenarios. On the second drivers and third drivers of modal shift and vehicle occupancy, in the trend-based scenarios, there are not a lot of changes by 2050, while in the most ambitious scenarios, there are reductions like 20% reductions of CO2 emissions by these 2 drivers. And the national low carbon strategy is quite at the middle between trend-based scenarios and the most ambitious ones. And finally, on the 2 last drivers of energy efficiency and carbon intensity of energy, which are more technological drivers, the national low carbon strategy is much more ambitious and more ambitious than the other scenarios, and sometimes with projections which are very difficult to obtain, as there are really hypotheses of strong technological development which are not observed, at least for the moment, for the beginning of the studied period. So there are also possibilities of more ambition, especially on the sufficiency drivers, compared to the national low carbon strategy. And another thing about the past trends and the evolution by 2050 is that we have observed for mobility that there is a strong link between the mean speed of mobility in France and the kilometers traveled, because the mean transport time each day for the population is around 1 hour per day. And then as the mean speed of travel has increased, it allowed to increase also the distances, and then with the territory planning and with increasing distances for local, for commutes, for daily travels, but also for long distance travels, where there is a strong increase in terms of distance and in terms of transport demand for the last decades of the 20th century. And this increase, as we have already seen, this increase in terms of distance has also led to an increase in terms of CO2 emission until the beginning of the 21st century. And for the prospects by 2050, in terms of mean transport speed evolution, it's projected that even for the national low carbon strategy, the mean transport speed should not increase, as there are especially modal shift, which is projected from cars to bikes, which is a more trend in terms of slowdown of mobility. If this modal shift is not only in the center of the big cities where bike may be faster than cars, but if it's globally on the territory, there is more a trend in terms of stabilization, of small reductions of the mean transport speed. But as we've seen that this strategy also projects an increase in terms of distances, it would mean that the transport times of the people would increase if this strategy will be fully implemented as it is in this scenario. That something that we can contest, or something that we maybe that will not be like that in the reality, as it's not that we have what we have observed in the past years and past decades in terms of mean transport times and duration. And finally, the last thing is about this important decrease of transport emission, which seems to be very difficult without a more important ambition on the different drivers, and especially on the efficiency drivers. So in order to see a bit more the interactions and the links with ICT, this figure is from my thesis, and then I will add some elements about ICT. It's I think that in order to understand what can be the role of ICT for mobility, it's mainly in terms of interactions between the different measures and the different evolutions that we can have in the mobility sector, and what are these the interactions with the 5 different drivers of energy transition. So, for example, this table aims at giving information. For example, when we increase when we try to increase carpooling, there may be some rebound effects when it's in orange, some rebound effects on transport demand or modal shifts. That's what we have observed in France for long distance carpooling, as a lot of users of this service used or would have used train, or would have not made the travel if the service did not exist. So this is a kind of rebound effect where the service displaces or changes the behaviors and especially in terms of reduction of the initial positive impact that we could have obtained. But for other drivers or for other evolutions, like when we encourage biking, there may be some positive interactions, like the fact that bikers try to reduce their daily kilometers traveled when they are used bike instead of cars, as there is some effort in order to ride a bike, and it's a bit less. It's a bit more. It's slower than a car. So there is a positive interaction with the moderation of transport demand, as it encourages to have more proximity in the lifestyle and in terms of the different travels. So now I will add at the right of this table some elements about ICT, or especially some elements from a study from IDRI, which is an institute in France, which studied how the autonomous vehicle could be good news or not for sustainable mobility. And they studied 3 different scenarios and 3 different use cases for autonomous vehicles. And what we can observe in terms of interaction with the different drivers is that according to the different scenarios, there are not the same kind of impacts on these drivers of energy transition, especially if we have an individual car use scenario in terms of autonomous vehicles. There are some risk of rebound effects for transport demand, for modal shift, like more car use because it's easier to take the car when it's autonomous, and if we can do other things in the vehicle if it's a fully autonomous vehicle. There are also, but if we have other kind of scenarios, and especially the public transport autonomous vehicle scenario, it can be more positive for the energy transition, and especially encouraging to a positive modal shift towards public transportation. And according to vehicle occupancy, it really depends on the scenario. For energy efficiency, this kind of autonomous vehicle and eventually smaller driving and more eco driving can be positive for energy efficiency, but there are some effects in different directions, so it's not easy to exactly know in which direction it will, if it will be positive or not for energy transition. So if we take again these 5 different drivers, and if we see some examples, some opportunities or risk of ICT for these 5 different drivers, we can mention some opportunities for improving or for facilitating these different drivers, especially for reducing transport demand, like remote services or teleworks that may reduce transport demand if there are not rebound effects in terms of telework or other services. For public transport with more information for passengers or for services like systems like mobility as a service, it can facilitate the use of public transportation. We can implement shared biking systems. ICT can facilitate also the carpooling with apps and real-time services. ICT can may facilitate also eco-driving or electric vehicles charging management. So there are some opportunities with ICT, but there are also some risks, especially as I've mentioned, the risk of increased mobility and distances by facilitating the mobility. There is the same kind of risk if we facilitate car use, like apps like Waze that allow to reduce road congestion, and then it may shorten the car trips, facilitate these trips, and then to have a kind of rebound effect from public transportation or for biking to cars. This is the same kind of effect for in case there will be an individual autonomous cars scenario. And in terms of energy efficiency or in terms of resources consumption, there are also some risk in terms of increased mass, increased energy and resources consumption for connected vehicles, for autonomous vehicles, or for the implementation of this ICT for mobility. And it also questions what is the kind of vehicle that we can consider to be the right vehicles for the future. There are some technological options with autonomous cars, which can have more consumption in terms of energy and materials, but we can also have a more sufficiency option in order to reduce the environmental impact of the vehicles today, and especially lighter vehicles, which are more connected to the real use of daily mobility. Especially with this kind of vehicles, which are called like intermediary vehicles between the bike and the car, which are vehicles which are less costly compared to less expensive or cheaper compared to cars, and which can be also useful for the daily travels, and maybe that can also be a bit faster or carry more load or people or children with compared to a classic bicycle. And my last slide with some key points of the presentation. So in terms of context, there is this target of carbon neutrality in France by 2050, which implies to reach almost full decarbonization for the transportation sector. There are various different environmental, social, and health externalities of transport, not only about climate change, but there are a lot of sustainability challenges for this sector. Transportation speed influences distances and also CO2 emissions. So that's what we have observed in the past years and decades. So if we want to reach the goal in terms of carbon emissions, but also in terms of other externalities, we really need to be more ambitious on the 5 different drivers or 5 different levers of energy transition, which are about the limitation of transport demand, modal shift, vehicle occupancy, energy efficiency, and carbon intensity of the energy. And we have seen that in the different scenarios, the technological options are really necessary. But they are not sufficient alone in order to reach our climate targets, especially in the short term, where demand side measures and sufficiency are really necessary in order to reduce the emissions. And in terms of the role of ICT, some some insights about is that there are both opportunities and risks from ICT. It's one of the numerous drivers which influence travel behaviors and emissions, so it needs to be connected or to be coherent with the other drivers or the other means of the other drivers of energy transition. The main opportunities are linked to the improvement of the efficiency of the transport system, but this opportunity may also be a risk if this efficiency is more favorable for high-emitting transport modes, where it can lead to some rebound effect if the efficiency is compensated by behaviors that consume more resources and energy. So thank you for your attention.
So I think we have one question here, one there. So, okay, 1,000 of questions. Let's go.
Thanks. My question is about the importance of territorial management and the role of the state. Maybe you wondered before what was the main thing locking the situation of the demand to an increasing curve. Do you have any information about the lock preventing the decreasing of the demand and preventing any territorial management for that point?
Yeah, this is a difficult question. Thank you. About there is kind of lock-in due to the territory planning. We had an important urban sprawl in France, but also in the other countries, due to rapid transport modes of transport, which facilitate the increase of transport demand and increase the distances of travels. And once we have this territory planning and these lifestyles which are dependent from these important distances, it's very different, for example, for walking or even for biking, to increase their share importantly if there are a lot of long distance travels. But we already know, especially in France, that we have a lot of short travels which are still made by cars that we could replace by biking, by walking, but public transport also. But we need to, I think, at least to change the objective of territory planning to go towards an objective of more proximity in the territory planning and in terms of the evolution of lifestyles, in terms of location of the new building, new houses, and I think this is not the case for the moment in France. We still have this trend of urban sprawl which is continuing. So at least we have to change this objective and to try to add on existing building and existing urbanization to have some different points where we can have a local already difficult in French, so in English. I think some proximity points in different parts of the cities, and to create new proximities in the daily life in the future. So it can be an important driver within this transition, as we see that the increasing transport demand is a major risk in terms of CO2 emissions, especially for also for long distance travel, like air transport, which is still increasing its demand and emissions. So it's important to have this objective of limiting, of moderating this transport demand, but it can't be the only driver, as we know that we have also important lock-in, especially for urban planning and the urban territory, which moves quite slowly. But yes, we need to act right now in the right direction as 2050 arrives quickly.
Thank you. I'm sorry to interrupt. I will maybe ask you to keep the answer a little bit short, as we have like thousands of questions and like 15 minutes running. But thanks a lot.
Hello, thank you for the presentation. So my question is about slide 14. If you can just switch. Yes, and here so in modal shift, you talked about public transport, and you said that information, mobility as a service, shared biking system could change something. So I was thinking about my city, so I'm going local, which is Marseille, which is like the second or third city in France. It's a big city. So we have very, very, very poor public transport means. And to my knowledge, there is only one tram line that is going to be built in the next 20 or 30 years. So I don't see how this public policy in Marseille is going to change things, because for people who need a car to work, I'm not talking about the people that have the money and the possibility to have shared bikes, to have electric bikes, etc. I'm talking about them who need cars to work. So it's very important, necessary for them. And they cannot use public transport. And for me, it's like the only way, if we make a good public transport offer, is the only way that they could change things. And second, in Marseille, we can take trains to go everywhere because it's a big city. But we can also take planes to go everywhere. And the price of plane tickets, it's very low regarding the price of train tickets, public trains. And the government did not want to tax plane tickets for those cities where we can take trains. So it was a proposition from Alternativa Greenpeace that government taxed all the all the train voyage that were the same as planes. So that people could not take the plane to go somewhere but the train. So if we don't have government policies and municipal policies, do you think it's going to change really in 2050?
I think that ICT may help for this, but if we don't have enough offer of public transport, ICT can't change the use of public transport if there are not like infrastructure, like services, like frequency for the public transportation. It's not possible to have an important modal shift. So ICT may facilitate this change if it's used properly, but it's not sufficient by its own, as we really need an efficient offer from alternative transport modes, alternative to plane and to car. But if we also want a real modal shift, we both need to facilitate the use of the of public transportation, of biking, walking, but we also need to discourage in some sense also the car and plane, because in the past years we have encouraged all the transport modes. More recently about biking, public transportations for some years, but also cars with new infrastructures like highways, also with planes, with still a number of projects in France to have bigger airports. So if we facilitate the use of all the different transport modes, we can't have an important modal shift. So it's both encourage and also less use of car and plane. And so we have to, we need also policies in this sense.
My question was about the slide 11. I didn't understand why do this scenario plan an augmentation of the distance, because as it is correlated with the speed, and you plan a rapid state of the speed.
Yeah, it's not something for the speed. It's not something calculated by this strategy. It's calculations that I made considering that the mean speed of the different transport mode should be quite stable by 2050. The mean speed of biking, of walking, of cars, all these transport modes, there are not a lot of variation in terms of transport speed by mode these last years. So I calculated that the modal shift implied by this scenario would mean that there would be a small slowdown or a stable mean transport speed in this scenario. But that's not something that the low carbon national strategy planners did. So that's something I try to contest in terms of strong increase of this transport demand, as I think it's not really possible if the mean transport speed is stable, and it's not really a good thing for sustainable mobility also in terms of emissions, but also in terms of other transport externalities. So it's not something that the strategy calculated by their own and saying that we want to have more time in transports. It's just something that it's not fully coherent in my sense.
Yes, for this slide, I have one question. Do you count the imported emissions when you have a scenario like this for emissions, for example, for electric cars, please?
I used directly the data from the scenarios, so for the national low carbon strategies, but also for the other scenarios, and generally these other emissions due to the production of energy or the production of vehicles is counted within these scenarios, but in other sectors like industry for the car building, like in the energy sector for electricity, for electric cars, etc. But I did not get the data in order to make this decomposition with the full life cycle emissions, because generally it's difficult to isolate the the transport part within the industry, within the energy consumptions, and so on. So, so it's a limitation of this kind of curve or on this kind of decomposition, especially when we are approaching 2050. It's that the majority of transport emissions are indirect emissions, as long as we are moving to electric vehicles. So more and more in the future, we need to make analysis in terms of life cycle analysis in order to fully take into account all the impacts.
Okay, I think we really have time for a really small question and small answer.
Thank you very much for the presentation. Basically, you showed that there was a technological bet and a societal bet with the sufficiency and so on. And so I was wondering, do you understand why the SNBC has a so strong technological bet while everyone else does not quite agree? And what's your vision about how realistic it is?
I think the main reason is about the vision of energy transition, which is kind of vision of green growth. And that's also what we hear from the discourse from the government. This is kind of, yes, a technological bet for the future that it will be sufficient to reduce our emissions. What we see is that at least for the short term, it's not enough because there is quite a long time for technologies to diffuse or to be important within the car fleet, for example. And it's also a bet because we don't know if it will be possible to electrify all the fleet in France, but in all the world, all over the world, if we don't have also sufficiency in terms of materials use, and also in terms of energy use, because there are a lot of electric for passengers, but for example, for freights, it's more difficult to have electric trucks. So it's also important consumptions of biofuels, and we are not sure to have enough biofuels or sustainably sourced biofuels. So I think today there is this vision of green growth, but maybe there are also in the discourse some changes with some plans for sufficiency. We'll see if there are an important ambition or not, but with with the crisis in terms of energy prices, with the difficulty for energy importations and so on, maybe we will have different policies in the next few months and years. I hope so, because it will be very difficult to reach the targets, or the different targets of sustainability without an important sufficiency in mobility.
Thank you.
Thank you, Aurélien, for all the answers and your talk.